Good evening. Welcome once again to the new session of Pre-Med Pro. We are continuing the nerval coordination, and today we're going to continue with the stimulus of the nerve as well as the conduction of the nerve impulse. So let's start with this today's lecture, and hope you are all doing fine and many of you have completed the Neet application process. So if you have not completed till now, please do it and keep focus on your studies. So this today we will start from the stimulus. So, as of yesterday, I have ended up with the nerval stimulus, and we are continuing with the same part. And because I have not completed the nerval stimulus after the last lecture, and so today let me draw some figure first. Okay, so now the nerve impulse, this is the plus terminal, let it be, and this is minus. Okay, so now this is the axon membrane, RMP polarized, and to RMP depolarized. In the polarized state, it is minus 70 millivolt, and in the depolarized state, it is plus 30 millivolt. Okay, now the stimulus is given. If the stimulus is given, what will happen? The sodium channel gate will open, so the sodium ion will start to enter. Okay, now when the sodium will start to enter, this is opened. Now the sodium voltage gated channel is open. What happens? Sodium voltage gated channel is closed. Now potassium voltage gated channel opens. When the depolarization occurs, this change in potential is known as action impulse. Potential is known as action potential. Okay, so this channel, it is known as the action potential. Now what happens? Now here, when the stimulus is given, what happens? The stimulus is given. This was threshold stimulus. That is the minimum stimulus that is required. Threshold stimulus. After that, it is the minimum value stimulus given to generate generate an action potential. Now what happens? This is plus. sodium, and this is potassium, VGC open. VGC open. Now what happens? This is the sodium channel, and now the VGC is closed here because the potassium VGC is open. Now what happens? As potassium voltage gated channel takes more time to close, so more potassium ion goes outside, making the membrane hyperpolarized, makes the membrane hyperpolarized. Okay. Now plus the IV threshold for hyperpolarization minus 90 millivolt. So potassium voltage channel takes more time to close. Okay. Now after this potassium voltage channel, and the sodium voltage channel gets closed, the membrane again return back to the polarized state, that is minus 70 millivolt. After both potassium and sodium voltage gated channel closes, the membrane returns back to the polarized state, that is minus 70 millivolt. Okay. So in this case, there are 5 steps. The step number 1, RMP, that is resting membrane potential, that is in polarized state. Step 2, depolarization, sodium voltage gated channel / voltage channel opens. Now repolarization, potassium voltage gated channel open, hyperpolarization. Okay, these are the steps is followed. Okay, these are the events. Now you have some points to remember. I am saying the points. You have some points to remember, such as a neuron is negatively charged. A neuron is negatively charged compared to the outer membrane. At resting membrane potential equivalent to 70 millivolt. Okay. Now next you have to remember, when a threshold stimulus is given, stimulus available, it causes sodium voltage gated channel to open via via which sodium ion enters into exoplasm, making inside positive up to plus 30 millivolt. This event is called depolarization. This event is called depolarization. Okay. Now the third. Now the sodium voltage gated channel closes. Now when the sodium voltage gated channel closes, potassium voltage gated channel opens. Potassium goes outside, again making inside negative. This is called repolarization. So it is called repolarization. Okay. Now conduction of nerve impulse. Okay. Now the conduction of nerve impulse. Conduction of nerve impulse. Conduction of impulse. How the impulse is conducted. So please wait, I am drawing a diagram. Okay. Sodium enters. So thus the sodium voltage gated channel opens. Okay. So now when a threshold stimulus is applied at site A on polarized membrane, the membrane at site A becomes freely permeable to sodium. Thus sodium comes inside. A site is then depolarized. Okay, A site is depolarized. Now in the next case we see again the current, as the current flow, here the current will flow, the current flows. Next again let it A, B and C. Negative, negative, negative. This is positive. Again positive. Okay, so inside must be positive, inside must have to be negative, must have to be negative. Now let this one, okay, is exchanged here, and the channel here, the sodium enters. Okay, now what happens, this is a sodium voltage gated channel. Okay, so it is depolarized, it is depolarized. So it is a resting membrane potential. Here the resting potential membrane potential is continuing. Now what happens, here it is potassium, no, potassium cannot be here. Now here, in case change in potential across the site A acts as a stimulus for the nearest site B. Change in the potential across site A acts as a stimulus, for nearest site B, due to which current flows occurs A to B inside, B to A outside. The circuit is thus complete. Okay. Now A, B, C. Here, see, the sodium voltage gated channel is open. So what happens? See, if the outside is negative, the inside has to be positive. Now this causes a stimulus here, and this positive will causes a stimulus in the negative side. Now what happens? Here the potassium voltage gated channel it is repolarized, this is depolarized, and it is maintaining, the C site is maintaining the resting membrane potential. Now the change in potential across B acts as a stimulus for C. Now what is happening if I write it in a gist here? In the picture number 3, the sodium voltage gated channel opens at B. See, the sodium voltage gated channel opens at B site. Okay. Now in second case, the polarity is reversed. The polarity is reversed. Okay. And the third side, action potential generated at site B, impulse arises at D from A, and this sequence is repeated entire axon, along entire axon. ये सीक्वेंस एंड एक्सॉन में पूरा का पूरा ही रिपीट हो जाता है. ठीक है. सो राइट अ नोट. this question comes in the Neet. This technical question comes in the Neet. Conduction across myelinated versus non-myelinated. Okay. So here we write the non-myelinated and here myelinated. Okay. So in non-myelinated, let it be a non-myelinated. Okay. Now, in non-myelinated, what happens? Non-myelinated. Slower conduction as free conduction across occurs throughout the neuron. And in case of myelinated, plus plus minus minus. Fast, it's very fast. Myelinated is more fast than the non-myelinated. So it is the node of Ranvier, and these are the myelin sheath. Okay, so what happens? Conduction occurs occurs only across the nodes of Ranvier. नोड ऑफ रेनवियर की तरह ही ये कंडक्शन होता है और faster conduction of the nerve impulse. Okay, so myelin sheath is basically insulated and free conduction is not possible. Free conduction is not possible. So I think the action potential has been completed, and the next lecture I will start with the synapse. Okay, so please go through it. It's a critical topic and you need to rewind this video 2 to 3 times to understand it. So I'll say that please take this video 2 to 3 times, and if you find any problem, I think some problem may come, so please write it in the comment box. Okay, so till then, good night and have a nice day. Please share, subscribe and like this channel. Bye bye.